Another big issue with climate change is the loss of sea ice, glaciers on land, and also ice sheets. In the Arctic Ocean, we see that summer Arctic sea ice has declined much faster than the computer models originally predicted it would melt. And at the rate that it's melting now, we might not have any summer sea ice within about 50 years. This is important because animals like seals and polar bears depend on that sea ice they get up on the sea ice and they use it to rest or to sun themselves or to hunt for food. And then fish depend on the sea ice, they go underneath it to eat. And so all of these different animals in the Arctic Ocean depend on that sea ice, and it's slowly going away. So why is it melting faster than we originally predicted? One issue is that there's a positive feedback loop in which a little bit of melting of the ice leads to a lot more melting. And this happens because ice tends to reflect. Ice is a white surface, and white surfaces reflect light from the sun back up into the atmosphere and into space. And so ice has what we call high albedo or high reflectivity. It reflects most of that energy back out into space. But darker surfaces like open water, rocks, and vegetation, those absorb more heat. They have a low albedo or low reflectivity. So they absorb that solar energy, and then that causes warming in the surrounding area, which then leads to more ice melting when we're talking about sea ice or glaciers that are on land. And so that's why a little bit of melting causes more warming and then in turn more melting. In the picture on the slide, we see Exit Glacier. Exit Glacier is in Kenai Fjords National Park. It's part of the Harding Ice Field in Alaska. This glacier has retreated, or it has lost about 1.4 miles of ice on its terminus, the end of the glacier. And it's not because it's moving back, it's because it's just losing that ice. So it's somewhat of a confusing term to say it's retreating, because it's not actually traveling backwards. It's just losing ice at the terminus or end of the glacier. This glacier has lost 1.4 miles of ice. So this whole valley that you see in the picture was full of glacier in the 1800s, and now it's simply not. The glacier has melted back, and now it's a river and a valley. There are two main causes of sea level increase. And so when we talk about melting ice, that leads to sea level increase. And this is referring to the melting of land-based ice. So that would include all of the ice on Antarctica, on Greenland, and then all of those land-based glaciers. And as these melt, all of that water is draining into the oceans, and it's causing sea level rise. This is not talking about icebergs that are already in the ocean. So that Arctic sea ice is not on land already, and so that's not contributing to sea level rise. But it is contributing to that positive feedback loop of melting. If all of these ice sheets were to melt, so all of Antarctica, all of Greenland, and all the glaciers, sea level would rise more than 20 feet. And we're not expecting that in the near future, but we are expecting significant melting, such that we're expecting the sea level will increase between 3 and 6 feet by the year 2100. Another thing that we see that causes sea level increase is that as the oceans are warming, that water is expanding slightly. And so it's not a huge amount of expansion, but when you're talking about a whole ocean full of water, it leads to a lot of expansion just because the volumes are so large. And so that also leads to sea level increase. So in this slide, we see a picture of a map of Florida, the southern tip, and it's showing a projection of what Florida will look like with a 5-foot sea level rise. And you can see in this picture, we're missing some pretty big city, well, a couple of pretty big cities. So Miami is now underwater. Fort Lauderdale is mostly underwater. Some of Coral Springs is underwater. The Florida Keys are underwater. And so this would be a huge impact on states like Florida that are very low and coastal. regions.